Let's take a look at processual quality, where I want to emphasize two components: transparency on the one hand and replicability on the other hand. Also because replicability and reliability are often not well distinguished from each other, or students have a tendency to mix them up. So I want to emphasize this is a processual aspect and not a content quality aspect. But let's first look. But let's first look at transparency. Transparency is pretty straightforward, that in all steps of the process of data collection, all meaningful steps are documented as well as possible. That includes the origin and the structure of the sample, the measurement instruments that were used. So if possible in any way, document the entire questionnaire, the entire codebook, the entire interview guide, the entire observation schedule as an appendix to your publication. So a lot of this deals with what do we get in a publication in the end. And any training of data collectors should also be reported on, and materials shared as much as possible. So which test articles were coded, for instance. Documenting the process of fielding the study and whether there were any irregularities, like one interviewer not getting fired because they didn't really do any interviews but just made up data that was discovered, something like this. And then also the steps in the cleaning, preparation, processing and analysis of data, and other methodological information that may vary between the different data gathering methods. That's why we look into each data collection method specifically on its own, and any information that may be helpful for understanding what exactly has been done to produce the results of the study. So these are very important components to include also when you write up the method section of your study. This will be the core questions that this will have to answer, besides the general structure of the design and the specific data gathering method that has been used. Okay, and ideally, though it's too much to include with the publication or the report itself, you would usually try to share the data and the code for data analysis in an online repository for research data, particularly for reproducibility and easy meta-analysis. Okay. The second component, and closely related to transparency, is replicability. Replicability refers to whether the results of a specific study can be reproduced, particularly if they can be reproduced in other settings, but similarly set studies. So we don't worry about a result not being the same if the setting is very different, right? Then we would say this is a finding that's not very puzzling, and that's probably just the reality of the difference of the settings. The big thing is what do we make of it if an attempt to reproduce a study in as similar a setting as possible doesn't succeed and we find other results. And the strongest this is if it's done by other researchers. So if lots of different researchers from different research groups reproduce the same results in similar settings, that is good evidence that this mechanism that a study says it shows is really there in reality. So, and to achieve replicability, I mean, it's not your fault if your results don't replicate, but it's your duty to ensure that replication studies can be done as closely matching the initial study as possible. And therefore, again, transparency is key. Extensive documentation is a prerequisite for replicability. And that's even good if you are doing that in your own research group. So you internally document everything as closely as possible so you can replicate your own results, but also by outsiders, other research groups. That is the strongest test of replicability, and therefore transparency is key here as well. Replicating previous studies often has relatively low status among researchers, which is a pity, because there is often quality criteria used to assess research proposals and research publications, such as novelty or innovativeness. And if you say, my mission is to replicate some other study that is neither novel nor innovative, but nevertheless is an important part of science. And the thing that usually is being done is that you combine a replication with some extension. So you come up with an additional moderator or mediator and so on to look for complications in the relationship as well as trying to replicate something. So otherwise we can't really get to the bottom of the specific cause-effect relationships. We are again in this area of rigid testing research, particularly. Their replicability is of very high importance. And getting replication studies published is also difficult, and this leads to a problem that we call publication bias in the record of published studies. And so because studies with that seem to support a hypothesis have a higher probability of getting published, we might mistakenly think that the evidence for a relationship is stronger than it actually is, because those studies simply get thrown out that don't seem to show the relationship. Good. So it's up to new generations of scientists to enhance replicability and avoid so-called replicability crisis as we have observed them in some fields. And strategies to enhance replicability is, on the one hand, if you are an editor of a scientific journal or a reviewer for a scientific journal, to be aware of these biases towards novelty, towards innovativeness, and against replication studies. So that would push for changes in editorial practices. And if you are a funding agency, it's the same thing. Don't push too hard on the innovativeness front. This allows the important task of replication. And you as a research practitioner should avoid practices such as p-hacking. So that means that you investigate many possible relationships and you don't really have a plan which one you test for and which not. And then just focusing on those that are displayed as statistically significant, as if you had known beforehand, right? But you didn't know before, you just learned that through the testing, and now play along as if that was the only test you have done. And this makes the p-values, the statistical significance tests, basically worthless or very hard to make sense of. So they will have a much higher probability of an alpha error than the test actually seems to show. Or the other strategy you should avoid is harking, hypothesizing only after results are known, which is basically closely related to p-hacking. So p-hacking doesn't mean you can't investigate lots of relationships and see for and check what sticks, but you just shouldn't report that as tests of a specific scientific research hypothesis, right? There you just say, okay, I threw a lot of stuff against the wall and checked what sticks. And this explorative way of framing it doesn't suggest that this is a real test of statistical significance for a hypothesis test. So you avoid the harking. So you don't hypothesize. You only show what the results were of an explorative analysis. Okay? And one strategy to avoid both is to pre-register your studies before fieldwork, such that you really formalize what your expectations are, what the hypotheses are, and then you only investigate these hypotheses, or if you investigate other hypotheses, you clearly mark them as something explorative that hasn't been expected before. And then you're on the safe side in that regard. If you want to learn more about that, you should revisit the research process lecture, which has an entire subunit on open science, and their pre-registration is also dealt with.